Hi guys, welcome back. So here we are today solving some problems based on log and exponential functions. In the previous session, or in the previous video rather, we had seen some laws related to exponents, laws related to logarithms, and some characteristics of logarithms, and from where did logarithm came into picture. Yeah. So today we are going to start looking at some problems. The questions would look somewhat like this: convert from exponential to log form. Now, obviously, they are not going to ask these kind of questions in your board exams, but obviously, this kind of becomes a skill which is very basic and it is needed for solving problems which are related to questions from the past paper. So now they're saying convert from exponential form to log form. Right now, in any of these equations that you see, you don't see logarithm over here, right? Which means this is right now in the exponent form or exponential form. We have to convert it into logarithmic form. So for example, if I'm looking at the first one, it says 10 square is 100, which means we are not supposed to send the 2 on the other side. Instead, we are supposed to send the 10 on the other side, and 2 comes in the base. Over here, this becomes log of 100 to the base 10. Yeah. Similarly, for the second equation, if you take the 10 on the other side, you have x left over here. You can write it as log of 200 to the base 10. When the 10 goes there, it comes in the base of logarithm. Over here, 10 raised to x is 0.05. If you send the 10 on the other side, you have x equals log of 0.05 to the base 10. So in all the cases, you sent 10, which was the base, on the other side. We never send the power, we send the base. Okay, moving on. Right now, in all these equations that you see, you will see that there is log written, which means here we are asked to convert from log form to exponent form, which means we have to get rid of the log, right? So if we have to do that, we are going to look at uh, sending the 10 on the other side. So this becomes 10 raised to 4. Okay, the 10 goes on the other side. Similarly, let's say if we have this over here, then the 10 goes on the other side, it pushes the 1.2 in the power. Yeah, again you'll send the 10 on the other side to get rid of the 10. That makes it x equals to 10 raised to minus 0.6. Okay, perfect. Moving on. So this was a skill of converting from log to exponent, exponent to log. Yes, this is something very basic. We should always know how to convert any equation from one form to another. Okay, you might want to try some more questions based on this uh, from any of the textbook that your school follows. Yeah. Moving on, something as basic as solve this equation will be called a logarithmic equation. It's a logarithmic equation. And because they have said you have to solve, which means you have to find the value of x. If you have to find the value of x, then you have to send the 2 on the other side, rather isolate the x. That makes it 2 raised to 3. Again, here we just simply converted log form to exponent form, and I have my answer, right? Perfect. Moving on, similar question, exactly same idea. I'm going to apply the same thing. You will have x equals to 3 raised to 2, so x becomes 9. Okay, perfect. Moving on to the next one, it says log of x to the base 4 equals 0. I want the value of x. It becomes x equals 4 raised to 0, and from law of exponents we know anything raised to 0 is 1. Yeah, okay. And if you look at the last one, it says log of 49 to the base x equals 2. If I were a kid looking at this equation, I would have been in two thoughts as to how do I work this out, because the variable is in the base. Don't treat it as anything else. In fact, just send the x on the other side. You will have something like this. 49 becomes equal to x squared. Now you just have to find out the value of x. You take the square on this side, that makes it square root of 49, and the value of x will be 7. Correct? Obviously, while doing all this, some people might have questions as to why did we not put a plus or minus sign over here. That is because, let me take you back a little, where we had said that if a is greater than 0, then b is also greater than 0, and that is why we had said that b can never be negative. Yeah, correct. I'm going to correlate that over here. That was log of b to the base a. I'll just scroll it back. If this is the exponent form, then x would be log of b to the base a, right? We had said that b can never be negative provided x belongs to a real number, correct? And we had also said that log of a negative number does not exist. Obviously, this would become, the b is basically 49 over here, which is already positive. Yes, and we had said that we would try to understand that if a was positive, b would definitely be positive, and we would never have a number which is negative in the base. Yeah, perfect. Moving on, I'm going to move on to the next one. Log of x plus 5 to the base 3 equals 2. That makes it, I want to find out the value of x. I have to isolate x, right? Let the 3 go on the other side. It makes it x plus 5 equals 3 raised to 2. So you have x plus 5 equals 9. The 5 goes on the other side, gets subtracted. You have 9 minus 5, which is 4. The value for x is 4. Yeah. Similarly, log of 3x minus 1 to the base 2 equals 5. So 3x minus 1 equals 2 raised to 5. Now what is 2 raised to 5? You have the calculator, you can do it with the calculator. So it should not be a very big deal. When you work out the math, you will take the 1 on the other side, it will become 33, and then the 3 goes in the division, you'll have x equals 11. Perfect. Moving on to the next one, it says log of 7 minus 2x to the base y equals 0, which means I can convert this into exponent form and I can write it as y raised to 0. Anything raised to 0 is 1. So we are going to replace it with 1, and further solving it would give me something like this. I have taken the 2x on the other side, it was subtracted here. When it went there, it became, or it got added on the other side, whereas when the 1 comes here, it gets subtracted. You have 6 equals 2x. It implies that x should be 3. Yes, something as basic as all of these. Now, again, will they ask a question like this? Obviously, it's a comparatively very basic question, but these are the building blocks for your questions based on past papers. Yeah. So let's move on to this. The next one. Now they're saying find the value of, yeah, if you had, say, if you had a paper which was without calculator, then there would be a little bit of brainstorming required in this case. Yeah. Although, if they were to ask you the same question in examination, then they would mention over you here that you have to do this question without using a calculator, and they will also mention that you have to show all your working. Yes, you guys heard it right. They will ask you to show all your working. And in such cases, how do we work this out? Now, whenever we are asked to find the value of, first thing that you should hit is the base of logarithm. If the base of log is 3, then I'm going to try and express this number as a power of 3. Can I write 27 as 3 raised to 3? Yes. And now, from the law of logarithm, which says that log of a raised to m to any base becomes m times log of a. Yes, which means the power comes into product. Correct? So I'm going to use the same thing over here. This becomes 3 times log of 3 to the base 3. From the characteristic of logarithm, if you remember, it is log of a to the base a becomes 1. That is one of the characteristic, which means if you observe here, log of 3 to the base 3 should become 1, right? So can I write this as 3 times 1, which becomes 3? Yes, that is your final answer for this one. Now, on similar lines, I'm sure you'd be able to solve these questions. Let me help you out with a question which looks a little haunting. Coincidentally, the letter is also H for that one. Uh, log of cube root of 7 to the base, no, divided by 7 whole squared to the base 7. Good part is everything can be seen in terms of 7, so life is comparatively sorted. If I were to simplify this, can I write cube root of 7 as 7 raised to 1 over 3? And then I have 7 in the denominator. If there's nothing, that means the power is 1, correct? And then all of that is raised to 2. Now, you are already aware that when everything is raised to something, that 2 or that power is given to each and every one in the numerator and denominator. So, can we say that 1 by 3 times 2, because this law of logarithm which says, in fact, not only logarithm, this is a law of exponent which says a raised to m, all of that raised to n becomes a raised to m times n, if you remember. Yes, which means the 2 and 1 by 3, they will get multiplied to become 2 over 3, and the denominator is 7 raised to 2. All of this is to the base 7. Yeah. Let me get rid of this. Okay, moving on. Can I write this as 7 raised to 2 over 3 minus 2, considering the fact that, again, laws of exponent, a raised to m over a raised to n can be written as a raised to m minus n. Yes. So 2 over 3 minus 2 should give me 7 raised to, I think it should give you minus 4 over 3 to the base 7. You can do that with calculator to check. And last but not the least, log of a raised to m is m times log of a. So the power goes in the product. So this power over here should go in the product, which means it will become negative 4 by 3 times log of 7 to the base 7. Now log of 7 to the base 7 will become 1. So your answer should be negative 4 by 3 for that question. Yeah, I hope you have understood this. You might want to try the rest of the questions, and if you're not able to get any of them, please mention in the comment section. I'll send the solution to you. Let's move on to something that is related to unknowns. And here in the question, see how the question dominates what is required in each different type of, you know, question. Here they are asking us to simplify log of x cubed to the base x. What do you understand by simplify? Right now, this looks a little more complex. If I use the laws of logarithm, I just have to take the 3 over here. This becomes log of x to the base x. Now, log of x to the base x, by now we have used it twice. I think you are already aware that log of x to the base x or log of any number to the same base becomes 1. So your final answer is 3. That's the most simplest version for this guy over here. Yes. Similarly, let me try one more question over here for you. Cube root of x to the base x. Yeah. Can I write cube root as x raised to 1 by 3? Yeah. And then life is sorted. That power comes over here. It becomes 1/3 log of x to the base x. Your answer should be 1/3. Done. Correct. Similarly, if you have log of x squared root x to the base x, I am going to simplify the powers. X squared times, can I write root x as raised to 1 by 2, and now the powers can get added. You will have x raised to 5 by 2 to the base x. Your answer should be 5 by 2 log of x to the base x, and we all know log of x to the base x is 1. Yeah. Obviously, as usual, the last question looks a little daunting every time, right? So I'm going to bias a little space over here, and I'm going to move it a little to the left. Paste. Yes. What us a little space. Let me try the H question over here for you. It says log of x square by root x to the base x, and that is raised to 3. Okay. First thing, I'll try to simplify whatever is inside over here. and then I'll give the power to everyone. So when I'm doing that, can I say it can be written like this? I'm going to break down it into as smaller steps as possible so that understanding becomes easier. Yeah. Now, obviously, the powers will get subtracted. Yes. And you will have 5 by 2, rather 3 by 2. My bad. Will be 3 by 2 raised to 3. And now, if I multiply if I multiply the 3 over here, I will have x raised to 9 over 2 to the base x, correct? Let me take the 9 over 2 over here. That gives me, which turns out to be 9 over 2. That's your final answer. So, I think this is a good amount of basic solving related to logarithms, and you might want to pause the video, try to solve the rest of the questions, and you can comment on the video if you feel that you need help with any particular question. Yes, so that's it for this one. See you in the next one. Thank you, guys.